Hi there! What I've got for you today is a video on capacitors. It's an electrical element, electrical circuit element, and it's got two ends, just like every other electrical element, but it has some interesting behaviors when we put it in a circuit with a battery. So a capacitor is something that stores energy. It's not quite like a battery, but it can behave the same way because it does have some storage capabilities. So it can store energy. And we give it the symbol of two parallel plates. So a battery has, if you remember, one big, one small. A capacitor is just two identical sized lines. And this is because the first types of capacitors we had were called parallel plate capacitors, and they were literally long parallel plates with a connection on one and a connection on the other. And so this is how the symbol came to be for capacitors. So they store energy, but if you'll notice, there's this line in between. That's because there's no electrical connection between these two plates. These two plates are totally independent of each other. There is nothing connecting the two. There is an insulating material between them. So that is the key, I guess, to understanding capacitors. So they store energy. On this plate, you can imagine it's like this big reservoir, a big container that can hold charge. And this plate here, again, it's a big container that can hold charge. So each plate, each side can hold charge. And when we put it in a circuit, well, let's see what we're going to do. So I'm going to have a capacitor, and I'm going to add a battery, but I'm not going to hook that battery up yet. So we'll have a battery, and then we'll have a capacitor, but we're not connecting them yet, so nothing can flow. There is no continuous circuit. If we think about the charges here, well, in this kind of regular, neutral, whatever you want to call it, normal system, what we have is a bunch of positive charges hanging out all over, and we have a bunch of negatives hanging out all over. And because it's neutral, it's normal, whatever you want to call it, we have equal amounts of positives and negatives. The battery, its job is to provide a constant voltage, a constant potential difference or pressure difference. And the positive end of the battery is just crowded. It's loaded with a whole bunch of extra positives. The negative end, negative, 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 negative. So the battery's job is just to keep this going. Lots of positives here, lots of negatives here. So before we hook it up, this is what the situation looks like. And if we imagine this little positive charge right here, what would that positive charge feel? Well, it's going to feel some repulsion from these, some repulsion from these, but overall, everything's neutral, everything is nice and smooth and even. It feels no pushes whatsoever. It doesn't want to go anywhere because we're all cool, we're good. Now we're going to hook up the battery. We add the battery to the circuit, and we've got our capacitor. All right, plus and minus. The moment we hook it up, we've got all these extra positives hanging out here and all these negatives hanging out down here. We also have all these usual positives, and I'm not going to keep drawing all the positives and negatives on the wires because that is a lot of work. So what I'm going to just do right now is focus on this little positive that I was looking at right here. So there's lots of positives and negatives, lots of positives and negatives, all nice evenly distributed everywhere except here. So what does this positive charge feel? Well, there is a ton of positive charges over on this side, and like charges repel. So these positives are going to be making this thing want to go that way. Likewise, these negatives are saying, hey, come over here, I like you. So this positive has a pull, pulling it in this direction, in a clockwise direction. What we end up with is the beginning of clockwise current flow. So we have some current flowing in this direction. Now, where does that positive charge end up? we've got the parallel plates here, and then we've got all our pluses. I'm going to get lazier about how many I draw. So that positive says, oh, I'm going to go this way. And it gets deposited onto that plate. All right, so it got moved, and then the battery says, oh, I got room. I'm going to shove another positive up into the space that this one left, pretty much. There's a whole bunch of positives, and every time one moves this way, another one takes its place. There is now another one, another positive that we can look at in the wire. And what does this thing feel? Okay, well, this thing still feels this attraction. And I'm going to ignore that. We're just going to focus on the positives right now. But you can see that that's going to still be there. I'm just going to focus on the positives. It's easier to draw. All right, so these positives are giving it that same push, that way. But now, instead of having just neutral, even numbers of positives and negatives here, this has an extra positive. There's going to be a tiny little push to the left. This positive is going to repel that one just a little bit, which means that our current flow is still going this direction, but it's not quite as big. Our next step, we can have the same situation, but now we're going to have the same thing happening, and that positive plate of the capacitor, this is going to start loading up with positives. So we've got, each time there's a positive, it's going to feel pushed this way, and we're going to dump another one on. Great, the battery spits out more to keep this full of charge, and it's just going to keep piling them on until we get a bunch here. So now what do we have for a positive hanging out in this wire? All right, we have from the battery the standard charge. There's a lot of positives pushing it this way. Now we have a lot of positives here repelling this the other direction. So we now have an increasingly even force. We still have a little bit of current going this way until we get to the point where it is totally even. So when we get to the point of having even numbers, and even kind of distribution or pressure or amount, density, whatever you want to call it, when we have an even density of positives here and here, well then we've got the push from the battery pushing it this way, the push from the capacitor pushing it this way, and that's going to add up to no force. And so this charge right here says, oh, I'm pushed this way, equally pushed that way, I'm not going to go anywhere. So our current becomes zero. We start with, let's see if I can make this a little cleaner. We start with a large current because there's a big push here. And then once we start getting charges here, we got some backwards push, so the current gets smaller, the current gets even smaller, and then the current goes to zero once we have balanced out. And I just want to stop briefly and talk about the negatives, but you'll see that we can ignore them. We can describe this just with the positives, which is just easier. I like staying positive. So if we think about the negatives, we've got this positive coming onto this plate. Well, this positive on this plate, the electric force goes through insulators. It can repel a negative, and so we've got a negative that can go this way. We've got a negative that can go this way. And so the negatives actually come back to the negative end of the battery. And so they're kind of refilling the battery, if you want to think about it that way. So we can talk about it in terms of positives and negatives, but I'm just going to focus on the positives because it's easier. It's just easier. So now we have what's called a charged capacitor. This capacitor has a voltage, a potential difference, a pressure difference equal to the voltage of the battery. So at this point, the voltage of the battery is equal to the voltage across the capacitor. And we have no flow, there's no current flow, and the capacitor is now charged. So this is when the capacitor is charged. Nothing's moving, there's no current flow, and there's no more charges getting pushed onto the capacitor plate. All right, so what we typically do then is we have this stored up charge, stored up energy if you want to call it that, on the capacitor. I'm going to unhook the battery. So if I unhook the battery, I still have lots of positives, and a little positive here. It still doesn't feel any push. And it can't go anywhere because there's no path. So right here, there is no flow. There is no current flow because there's no path. What happens if we take the battery out and hook that circuit back up? So now, we've got this. We have a whole bunch of positives, and if we imagine a positive in the wire, because remember, the wires, every single wire here has both positives and negatives. Those are neutral. So this positive says, there's a bunch of positives over there. I don't like that, and I'm going to be pushed in this direction. So this one's getting pushed in that direction, which means we have current flow. We have a movement of charge in this direction, and there's nothing opposing it, so we have a large current flow in the opposite direction to what we had before. Now this charge is saying, I want to get away from here, so it's going to go all the way around and pop onto that plate, which is going to effectively counteract, neutralize one of the extra negatives that we had there. You can imagine the process of what's happening here. If we've got now fewer positives left on this positive plate, then the force that is acting, that's pushing on this positive, is smaller. So if we have a smaller force pushing this thing, there's going to be a smaller amount of flow, and so we have less current flow. And then at the very last step, what we have is back to our normal, our neutral, and I'll go back and do all the pluses and minuses. So we get back to the point where we have equal numbers of positives and negatives in every bit of this electrical circuit. Back to normal, there is no flow. Nothing feels the need to move. So this is the process of taking a capacitor, charging it up until we get to this point, and then this process is called discharging. So we've got discharging the capacitor here. Now if you think about the current is one way that we can conceptualize the battery brightness, the bulb brightness. So what I'd like you to do is think about what the brightness of a bulb would be if I start with a bulb in the circuit. And let's just say I put a switch here. So there's a switch. When I close this switch, so when that switch closes, bloop, and the circuit is now complete, predict what is the brightness of this bulb going to be. Give it a moment. Think about the current flow as it became charged. Now we're not discharging, we're just charging up. We're not going to worry about this part. Just from here, up to charged. What do you think the brightness of the bulb is going to be? We start with a lot of current, now there's less current, now there's less current, now there's no current. Got your prediction? Did you do it? Did you do it? So we start with the bulb being very bright because we have a large current. So we start with the bulb being bright, lots of current. And then it dims as the current gets smaller and smaller. Eventually, it goes out. So it's a fascinating electrical device. I mean, we can get something that makes a bulb go from bright down to out. And so capacitors are really cool, and they have very useful purposes besides, making things go bright and then dim. The storage piece is what they're usually used for, because they will store energy and they can give it up in case suddenly your battery fails. And we'll be doing a little bit of practice with that. And I'll be giving you some circuits and asking you to explain what's going to happen in that circuit with a capacitor. Sometimes there'll be bulbs, sometimes there'll be bulbs and batteries, sometimes just batteries. But using this idea of what the circuit, what the charges in the circuit are doing, you should be able to start thinking about how a capacitor would behave in different types of circuits. Series circuit, parallel circuit, whatever else you've got. So that's just a general overview of capacitor. And there are some equations that we can do. We might get to them, we might not. But for now, this is what I want you to know about capacitors. Good job.